I'm Anil Kumar. In this series, we'll take a few examples based on polynomial inequalities. The question here is, the following number lines shows solution to a double inequality. Create a double inequality that has both a linear and a constant term for which this is the solution set. So we have a solution set given on a number line. The solution set is numbers, all real numbers between -5 and 7. So let me write down solution set here as solution set is x belongs to real numbers where x is between, so it is not including, those are the wholes, right? Not including -5 and not including 7. That becomes the solution set. Now you have to create a double inequality that has both a linear and a constant term for which this is the solution. So it is kind of a reverse question. We are given the solution and we have to create a double inequality. Double means in between two. So we need two inequality signs. So okay, so we begin with the solution set given to us, which is -5 is less than x, or you can say x is greater than -5 and less than 7. To create an inequality, we follow a process which is kind of reverse, right? So we already have a linear term which is x. If I add 5 or some number, both sides, let's add 3 for example. So let's add 3 to all terms, then what do you get? So if I add 3 to all terms, look here. We already have this inequality. We are going to add 3 to all terms. We have this inequality, right? So what we are doing here is we are adding 3. We have +3 plus 3. The inequality remains the same, correct? Since we have added one number to each part. But now what I have done here is the center term has been changed to a linear term and a constant. Do you see that? So we have a linear and a constant term. So I could now write this as -5 plus 3 is -2, correct? And we have x plus 3 less than 10. So we have a double inequality, perfect, whose solution is the one we started with, correct? So that is how you have to solve such questions, correct? Now here is a practice question for you, right? Practice questions. When I was saying number lines, the second one, which I didn't draw, is for you to practice, correct? So let's say we have a number line here, and let me trick you this time. So we'll start with 0, okay? We'll start with 0 and we'll fill this up. We'll fill this up, perfect. We'll fill this up and let this be, let's say 0 and 7. Can you provide a double inequality with a linear factor and a constant whose solution is all the values between 0 and 7, both included? So you can pause your video, answer the question, and then write down the solution. Here is the answer for you, okay? The answer is we're looking for x value which is greater than equal to 0, right? And less than equal to 7. We can add something, add anything. You could add just 1 also, right? So we could say 1 and x becomes x plus 1, and then we can make 7 plus 1 as 8. So that is the double inequality, right? Which has a linear and a constant term and whose solution is given here on the number line. So when you have a filled in hole, it means the values included, correct? Okay, let's move on to a different kind of question based on polynomial inequalities. So now we have a double inequality and we'll try to solve this one. Okay, so the double inequality is x plus 1 which is less than 2x plus 6 which is less than equal to x plus 5. How to solve it? Let me rewrite and then we'll try to solve this inequality. So we have x plus 1 which is less than 2x plus 6 which is less than equal to x plus 5. Now the first step is get rid of the constant from the center, which is plus 6. So we'll do minus 6 in all the terms. We could write this as x plus 1 minus 6, 2x plus 6 minus 6, and x plus 5 minus 6, correct? So we have subtracted 6 from each term. What do we get? We get x minus 5, and we get 2x in the center. Do you see that? And here we get x, and 5 minus 6 is minus 1. Now we need to find x in the center. We could do it by doing minus x in all the three terms. So this time we'll do x minus 5 minus x, 2x minus x, x minus 1 minus x. Do you see that? So when you minus x, then we get rid of x from the ends. So what we get here is minus 5, and we get 2x minus x as x minus x is 0, we get minus 1. So we have x which is between minus 1 and minus 5. I could write this as a solution on a number line where minus 5 is not included but minus 1 is included. Do you see that? So that becomes my solution. Minus 5 not included but minus 1 is included, and the solution is that x is any real number between these two, correct? So that is how you can solve your inequality. So that becomes the solution of the given inequality. So what you have learned here is that in case of a double inequality, do the same operation for all the three terms, right? Let's take up another example and then see whether you followed the method or not. Also remember, it is not necessary that every inequality will have a solution. Okay, this is important to understand and you will soon realize. Okay, let's begin by copying this question, which is minus 3x minus 4 less than minus 5x plus 9 less than equals to minus 3x minus 3. So first step should be get rid of this constant. We'll do minus 9 in all the terms. So we get minus 3x minus 4 minus 9, okay? And we have minus 5x plus 9 minus 9. And here again, we'll do minus 3x minus 3 minus 9. Is it okay? So when you do this, you get minus 3x. Minus 4 minus 9 is minus 13, right? So minus 4 minus 9 is minus 13. On this side, we get minus 5x. And here we get minus 3x and minus 12. That's what we get. Now, we could get rid of minus 3x from all the sides by adding plus 3x. Is it okay? So let's add 3x. So we get minus 3x minus 13 plus 3x. So that takes care of both the minus 3x, right? So minus 5x plus 3x less than equals to minus 3x minus 12 plus 3x. Now minus 3x plus 3x is 0, so you get minus 13, and here we get minus 5x plus 3x, which is minus 2x. In this case, we get minus 3x and plus 3x is 0, we get minus 12, right? So we have minus 2x in the center. To get x, we have to divide by minus 2. Now remember, whenever you divide by minus 2, you have to interchange the signs, right? So we are doing minus 13 divided by minus 2, change the sign. Minus 2x divided by minus 2, change the sign, reverse it, right? Minus 12 divided by minus 2. Now that gives you, 13 divided by 2 is kind of 6.5 positive, right? When you divide by minus 2. 13 divided by minus 2 is 6.5. And then this is x, okay? So x is greater than equal to, what is this number? It is 6. So that is what you get a solution. So it says that x is greater than equal to 6 but less than equal to 6.5, correct? So that makes sense. It could be. So what we have here is a solution which will be on a number line represented as, let's say 6.5 is here. So it is greater than 6. X is between these two values. Okay, so the value here is 6. Here it is 6.5. And this is filled in. This is filled in because it is equal to. Is that okay? And everything in between. Do you see that? So x is greater than 6 and is less than 6.5. Correct? You could also write like this. That you could write like this. Is it okay? 6.1 is the same thing. So that becomes the solution for the given question. Correct? Now here is a question for you. If I replace this minus 4 by plus 4, right? So then try to find the solution, correct? So I'll change this value to plus 4 and then try to find the solution, okay? So that is the exercise for you. So the question for you here is, let me write down the question. Question for you is, minus 3x, let me push this a bit, okay, plus 4, so I'm changing one value, right, less than minus 5x plus 9 less than equal to minus 3x minus 3. Perfect. So I changed the value. So I've added, instead of making plus 4, I made it, minus 4, I made it plus 4. Now find the solution of this particular equation. Well, the answer is no solution. Okay, so remember, this equation does not have a solution. So just show that this equation does not have a solution by solving the inequality. I hope that helps. I'm Anil Kumar. You can always share and subscribe my videos. Feel free to post questions. Thank you and all the best.